Hello, everyone. Thank you for joining. We're going to wait 1 or 2 minutes for everyone to connect. Okay, I'll start now. Hello, everyone. Welcome to this Hello Tomorrow webinar on accelerating deep tech innovation with AI in industry. I'm Fanny Delaval. I'm a senior manager at Hello Tomorrow. Hello Tomorrow was created in 2011 by a group of scientists and entrepreneurs who were convinced that science holds the power to positively transform the world, but that the traditional pathways from lab to market were not equipped to fully realize this potential. Since then, Hello Tomorrow has built the world's largest deep tech network, connecting over 10,000 startups, 1,000 venture capital funds, 3,000 corporates, and 250 ecosystem partners across 120 countries. So we achieve this goal of unlocking the power of deep tech through the Hello Tomorrow Summit, which is the largest annual event on deep tech in Europe, and through our consulting services to corporates and governments, from strategic foresight to understand which technologies are transforming your industry and how to leverage them to reinforce your leadership, to helping you to operationalize that strategy by finding the best startups and technologies to partner with and supporting the development of your collaborations. One key challenge that we've worked with our clients on is the use of AI in industry. What we've noticed is that most early AI adoption focused on narrow optimization, so automating tasks, improving utilization, cutting costs. While these uses were valuable, they were not as strategic in delivering high business value as we would have wanted with that deep tech angle that we have. So during this session, we will focus on the deeper use cases of AI, the ones that can bring deeper strategic business value to your company, but that are still relatively unexplored. Where we see with our clients and the broader economy, that's about 77% of manufacturers report using AI. Only around 12% have actually deployed it across operations at scales, with most companies still running vaguely isolated pilots. So I'm delighted to welcome our three speakers who have successfully piloted and scaled AI in industry use cases in their companies, and who will dive into our three key topics for today: AI to accelerate R&D and innovation, AI for intelligent operations and maintenance, and AI for critical systems and value chains. So I will let Juliette introduce herself. Juliette Mathioli, VP at THALES for AI.
Yeah, so I'm Juliette Mathioli. I belong to the technical directorate of the THALES group. as an AI fellow, and you will see during my presentation how we use AI and how we deploy AI in critical systems.
Thank you, Juliette. Mihir Sarkar, who is head of AI at Engie.
Hi, everyone. I'm glad to be here. So I'm Mihir Sarkar. I lead AI at Engie Research and Innovation, where I work at the intersection of AI and the energy transition. So I've been with Engie for the past 7 years, and I apply AI to very real physical systems like power plants, networks, or storage assets. Prior to that, I was an entrepreneur in Silicon Valley, and before that, a researcher at MIT on AI topics.
Thank you, Mihir. And Dominik Grabinski, the CEO of AI Bobby.
Nice to meet you. I'm Dominik Grabinski, so the founder and CEO of AI Bobby and its affiliate in Saudi Arabia, through Nexus. And I'm going to talk to you about how we develop a model that can talk to protein and help them expressing the best functionalities.
Thank you, Dominic. And now my colleague Ming-Shu will take the lead to give an overview of the agenda for the next hour and to kick off the session.
Yeah, thank you, Vanny. Thank you for our speakers. So today we have around 6 minutes together, structured in 2 parts. First is a peer sharing session across biotech, energy, and aerospace and defense to bring together different industry perspectives, exploring AI use cases, key challenges, etc. And then we will shift into 10-minute mini roundtable, where we bring everyone into a shared discussion, comparing how each sector approaches the same topic. So with that, let's get started with our peer sharing session right now. I will now hand over to Dominic for a 10-minute spotlight. The floor is yours.
Thank you very much. So in a very complex world, we are building a computational intelligence that makes protein functionality programmable. But in very simple words, we use AI to help scientists and industry to predict and eventually design how food protein behave in real world conditions. Will it gel? Will it hold water? Will it create the right texture? Will it still work after extraction, processing, formulation, and scaling? These sound very technical questions, but they are not. They are the business question. They are the industrial question. And increasingly, the more strategic question. Because more than 20 years and more than $20 billion has been spent in alternative protein, and the industry still replaces less than 1% of the $1.3 trillion protein market. You will ask why. The answer is very simple, because we still do not master functionality well enough. Of course, we can speak about sustainability, we can speak about climate, we can speak about nutrition, and food security. But if the protein doesn't perform in product at the right cost, under the real industrial condition, innovation stalls. And this is the problem we are focusing on. At AI Bobby and Nexus, we turn very fragmented scientific and industrial knowledge into structured intelligence. And then we use our predictive model to answer a very practical question. What is the most likely to work, under which condition, and where should the R&D team place its next bet? And so for me, it shows that AI is not about replacing scientists. It's about augmenting scientific judgment. It's about helping R&D teams move faster, with better signal, better prioritization, and better decision. Because in most industrial environments, the biggest problem is not lack of talent. It's even not lack of data. We have plenty of them. The real problem is that knowledge is everywhere, but usable intelligence is nowhere. It's in PDF, it's in all reports, it's in different protocol, in different vocabulary, and across different teams. So you have highly trained people that spend an enormous amount of time searching, cleaning, comparing, interpreting, rebuilding, understanding from scratch this data. And this is friction. And friction is the enemy of innovation. AI, when used properly, can reduce this friction dramatically. It can compress time, it can improve decision quality, it can reveal patterns faster, and it can help organizations to move from fragmented expertise to cumulative intelligence. That is where AI really starts accelerating R&D. Now I'm going to share some big learning that I had from that. My first one is that the AI must be tied to the real bottleneck, not to the nice demo, not to a fashionable business case, not something that is impressive on stage, but in actual industrial constraint. In our world, the protein world, that bottleneck is functionality under real world condition. Second is the quality of data, and context matter more than volume alone. 1,000 poorly structured data points do not beat a smaller set of well-understood, decision-relevant data. And third, AI only creates real value when it's become part of the workflow. How the team search, how they compare, how they decide, how they prioritize, how they learn, that is when the value starts to compound. But there is no one point bigger than the one I wanted to share you right now. And maybe this is the most important one. Innovation speed is not only a technological issue, because technology, we have it. It's also a collaborative issue. Food and ingredients innovation still operate in far much too in silos. Of course, some level of protection is normal. Some data are strategic. We need to protect our IP. But the current level of fragmentation is slowing down the entire field. Because in complex protein innovation, no single player sees the full picture alone. Nor the seed producer, nor the ingredient producer, nor the formulator, and nor the final brand. And when every of these actors protect data too tightly, the entire system is slowed. This is where I believe food still has something important to learn from pharma. Pharma also dealt in the past with highly sensitive data, but they built a framework to share, structure, anonymize, and then learn across all these data in a way that accelerates innovation. And I believe food is now approaching the same turning point. Because if AI is the engine, data collaboration is the fuel of that engine. So if I leave one idea here for you, what counts the most is not the AI for AI's sake. What counts is solving the real bottleneck. Structuring knowledge so it's become usable. Embedding AI into real workflow. And creating the condition for learning not only at the company level, but the ecosystem level. This is how we move faster. This is how we reduce the friction. And this is how we give deep tech innovation a real chance to scale. And with that, I'd like to hand over to the next speaker, because this question of data sharing and how industry moves beyond silos is absolutely central if we want to unlock the next wave of innovation. Thank you.
Thanks a lot, Dominic. Really interesting points here. Maybe Mimir, let me bring you in. What does this look in your sector? And we would like to hear your perspective here.
Yes, thanks, Dominic. And let's move from protein to energy. So my role at Engie is not just about AI models, making the best or the more accurate models, but about turning AI into operational systems that actually run in the field. So the question is, like Dominic mentioned, how do we make sure that we have the right data to do that? But also, how do we move from promising pilots, which potentially can create value, to AI embedded into operations? So I'll focus on a few use cases where this is working, what we've learned, sometimes the hard way, and what it means to scale beyond pilots. So first of all, if we frame the problem, the area where we're working, about AI in industry, industrial AI is quite different from the trending generative AI that we've seen in the past 3 years. What we talk about are long asset life cycles, sometimes 10 to 30 years. We're talking about power plants that have a long lifespan. We have high reliability constraints. We have data, but that data may be fragmented and imperfect. A lot of those data come from sensors and systems that have been historically capturing data. So we have a lot of it, but we don't always have the sufficient level of quality and organization management and structure to make that data usable. But that's an effort, an ongoing effort that can lead to very significant use cases. And there's also a strong coupling with real world systems and physical systems because we model those equipment and assets into AI systems. So the challenge, like I mentioned, is not just about building the models, but about integrating them into complex physical systems. So when we think about the value chain of energy projects, we think that AI uses a lot of energy and resources. That's something that's been documented in the past few years, especially generative AI. But AI can also be a lever for energy optimization and decarbonization. There's actually different types of AI. AI as a technology is not a monolith. There's a lot of different methods and tools that we use. And the goal that we have within the research and innovation department is to increase renewables energy production and availability, not just by growing the number of power plants, but by increasing operational efficiency and making sure that the assets we have perform at the utmost level of efficiency. So if we take the life cycle of energy projects, one of the things that we can do and that we have developed is around predictive maintenance. So as many of you know, maintenance activities on industrial assets need to be done regularly. So sometimes they can be reactive, sometimes they can be preventive. Since a few years now, we've several companies, several startups, many projects have been around predictive maintenance, so predicting when a piece of equipment is going to fail. So we do that, for example, on wind turbines, the mechanical parts. We do that on solar parks. We do that on thermal power plants, the balance of plant in those assets. And what we do is a combination of AI models with hybrid physical modeling so that we understand both the domain knowledge and the data that comes from automatically capturing data from those IoT systems. And the move that we're seeing now is not just about getting alerts for the operators and the technicians to take action, but actually recommending the next action because the AI systems can diagnose and can propose what the maintenance action will be based on the root cause analysis of the alerting and the problem that is going to be shown. So the value that we see in having those types of model is about reducing downtime, reducing penalties due to underperformance or non-availability of energy production at a certain time. We have optimized maintenance costs and potentially extended asset life because then we're not just following recommended maintenance patterns based on manufacturers, but really looking at the real world operations of these assets. If we look further in some other energy production projects, we have a lot of assets around biomethane production and biogas plants. So there we have, for example, developed a system that optimizes the feedstock for biomethane production. And what's been interesting to us in testing and deploying that system is that the AI behind it is not that complex. It uses a lot of data coming from those systems, but also a lot of rules coming from biological constraints, from regulatory constraints, from physical constraints around the physical installation of those sites. For example, how much feedstock it can contain, both solid waste and other type of organic matter. And taking that into account, both those rules and an automatic optimization problem that we're trying to solve with those AI models, we're getting significant value increase in terms of the production capacity, both from a revenue perspective, and we can look from the biomethane production capacity, but also from biomethane leaks and trying to reduce that so that we can decarbonize those activities. Another activity where we can look at optimization of operations is around the battery storage systems, where we look at performance optimization. And those kind of models have a direct impact on margins and a better asset utilization. So it's not just about growing the number of resources and sites and production capacity that we have, but also making better use of what we have. And the learning there is really about the fact that starting with a problem, the simplest AI model that you can build with the least amount of data and the most amount of expertise and knowledge, domain knowledge that you can have, makes the better usage of it. And the AI models that we run for these are not energy intensive because they run on classical machine learning types of algorithms. I'll talk about a last example in the field of inspection, visual inspection and field operations for networks and transmission lines, for example. In the recent past, we've tested drone inspection with camera-based both pictures and videos of transmission lines in towers and strings connecting those lines. And what that means is that we can augment the work that maintenance teams are doing on the field, reduce downtime, increase the safety of those teams that previously had to travel from tower to tower to inspect those lines manually with cameras and sometimes pilot drones to inspect a few of those towers. But then with automating that process, using computer vision to inspect defects that we are seeing in those images and those videos, it increases accuracy, and it is combined with technical operators that know the field to increase the likelihood of catching some defects that can lead to long-term deterioration. So that leads to safety improvement, to cost reduction, to better coverage versus manual inspection. So a lot of positive value additions beyond just cost improvements. So what we're seeing in all those aspects in terms of AI applied to the industrial sector is really a vision around physical AI. So we talk a lot about the kind of world models that are coming up in terms of describing physical assets and the reality around us. But we're really seeing very concrete use cases around digital twins augmented with AI. So using physical models with AI models that help us increase the performance and the speed at which we can do simulations, at which we can do optimizations. And those lead to better design decisions across the whole value chain, from design to operation to maintenance. And one of the things that we're trying to bridge through that value chain is bridging the data gap between each of those phases. The fact that when we design a new power plant, for example, capturing the data and building a digital twin at that moment can lead to better operations and maintenance in the long run. So looking at it from a perspective of what we tested and learned in the past couple of years in developing use cases with the business, is the fact that beyond model performance, what is really important is to integrate those AI solutions and models into workflows and processes and systems, making sure that we capture the data coming from SCADAs and automatons that capture the data coming from equipment through sensors, that we connect with ticketing systems for maintenance activities, that we connect with ERP systems and IT systems, and making sure that all the use cases, the AI use cases that we develop are part of the infrastructure from the ground up, that we don't have to make a huge effort in integrating the systems later on, but that adoption comes naturally from integrating them from the start. Another aspect is about data, the fact that data is necessary but not sufficient. Like I mentioned earlier, industrial data is sparse, it's messy. It comes with a lot of gaps, a lot of structural conditions that need cleaning, that need structuring, that need ontologies and semantics associated with it so that we understand what the data means and how we can make better use of it. And that requires domain expertise. For a long time, that domain expertise was in the head of people, of experts that had been working on maintenance activities on the field for a long time. we're now trying to extract that and augment the AI models and systems with that knowledge, and making the humans and the machines work seamlessly together by capturing that expertise into databases, data sets, graph databases, and ways to augment the models with that expertise. So we're now thinking about hybrid models that capture both data-based AI approach, where AI is trained on the data that comes from assets, and we augment that with physics-based approaches, so equations that describe a physical model, and augmented with unstructured data that comes from expertise, both in the way that technical operators work with and operate those assets, but also the way that operators and technicians log information in ticketing systems. So I'll end here for now and maybe keep some additional comments for the questions later.
Thank you so much, Mia. That's really great perspective from the energy sector. And for our audience, if you have any questions, don't hesitate to drop it in the chat, and we'll have dedicated time afterwards to discuss it together. And now let me bring in aerospace and defense. Juliette, we'd love to hear more about the AI use cases that you are seeing at those, especially in such critical environments.
So I will focus on critical system because Thales is developing a system for aeronautics, defense, security, and also cyber security and digital identity. And just to be sure that we are in line, for Thales, AI means bringing cognitive capacities to artificial systems. And when we speak about cognitive capacities, of course, we speak about perception. For example, if I am in aeronautic, I need to perceive flight tracks in an accurate way. So I want to enhance my radar with some AI capacities. Then I need to understand the global situation in order to identify if there are some track conflicts and to solve it. And I will provide some decision for routing, for example, for the air traffic manager, in order to anticipate any problem. I can also use, as mentioned by a previous talk, AI to support the overall life cycle of our system and so on. Just also to be complete, for us, AI means, of course, data-driven AI, as mentioned by the previous someone mute me, but also knowledge-based AI, because in our business, knowledge is very crucial. And as these two paradigms has some strengths and challenges, we claim that hybrid AI will take and combine strengths of the both approach in order to solve the opacity, the black box issue, the data drift, the combinatorial complexity, and so on. For us, data-driven AI, knowledge-based AI, and hybrid AI are very fundamental. As we deal with complex system and critical system, meaning that if there is any failure on AI or on the system, there will be a huge impact on life, on safety, on the environment, and so on. We claim that we need to develop trustworthy AI. And trustworthy AI is based on 4 pillars: validity, security in terms of cyber security, explainability, and responsibility. Validity means that we have to prove, to guarantee that the system is doing what it is supposed to do, all what it is supposed to do, and only what it is supposed to do, which is not so easy when you use continuous learning. Explainability, it's because we have most of time a human in the loop, especially, for example, if we use it in aeronautics, the air traffic controller must understand why we propose to reroute a flight. Cyber security is mandatory because we develop the critical system, and we have to be compliant with ethical framework, legal framework, and so on. Next slide. And that implies that for our industry, so critical system industry, we need to revisit all engineering methods in order to ensure qualification or homologation and compliance with all this new regulation and these new standards. Next slide. And there are a lot of standards, there are a lot of regulation and so on. For example, for THALES, following what it was done by UNESCO and OCDE, we proposed our THALES THALES Digital Ethics Charter with some guidelines. As we are an European company, especially French company, we must be compliant to the new Regulation AI Act with some very strict requirements in terms of explanation, in terms of robustness, in terms of accuracy, and so on. As we are working mostly in aeronautics, we also have to be compliant with a lot of new standards, especially the domain-specific standards of aeronautic and what it is coming from Eurocae or EASA. And in order to do that, we need to use methods and tools. And we are deeply involved in a lot of R&D projects. And I will mention the European Trustworthy AI Association, who provides methods and tools in open source way to support all the requirements that I have mentioned before. Next slide. So most of people are working on what we call the MLOps if we deal with machine learning, but if we enlarge with other AI techniques, we can call it AI ops, in order to support the overall life cycle of a critical system. For example, an air traffic manager systems. To support all specification and requirements based on a new concept coming from the automotive domain, which is called the operational design domain, because we have to also explain the intended purpose of the AI capacities, and it is mandatory for the AI Act, especially for high critical system, and to go forward to maintenance and deployment, because we will have to maintain our AI-based system during their whole overall life cycle. And for that, there are a lot of steps from data engineering, knowledge engineering, algo engineering, and so on, in order to go through validation and verification. Last slide, yes. It is why we need to think about an AI-based system lifecycle management. First, we need to support all risk management, the risk induced by the fact that you put AI in the system, through, of course, the overall design, requirement design, and so on. Don't forget cyber security, because it's very easy to attack an AI by another AI, and there are specific vulnerability. It is why we have in THALES develop a team called the Friendly Hacker Team, which are people like white hat, and they are specialists on AI vulnerability, and all our system based on AI go through this team. Of course, deployment, and we have to monitor during the overall life cycle the AI-based system, because sometimes there are some drift and so on. And don't forget also to be compliant to the overall regulation. And it is why we have also to provide some new governance on that, in order to first be sure that we are not developing, but also to ensure that we provide all the guarantee that I have mentioned in our motto, THALES True AI, for transparency, understable, reliability, and ethical AI. Thanks a lot.
Thank you, Juliette. Thank you to all of you for these very insightful presentations. We will move on now to the roundtable discussions. Thank you for everyone who's also published questions in the chat. Don't hesitate to write them down. We'll have a Q&A time to answer them at the end of the webinar. So the question we chose to ask all three of you for this roundtable is a common question that we get from a lot of our clients that are implementing AI in industry use cases. Why do most AI initiatives stall at the pilot stage? And what differentiates those who can scale?
You should start.
Okay.
Yes, go ahead, Juliette. Go ahead.
No, please.
No,
please, Juliette, please.
Okay.
Yeah.
So we at Thales, we are working in AI since 40 years. So we have already a lot of AI-based system in deployment or already deployed, since 5 or 6 years, it was mainly a craftsmanship aspect. And now we go to industrialization of our AI practice. And what we see, it's because there was a gap between an AI proof of concept and the AI-based system in an industrial way. And this gap was the AI engineering. And it is why, since now 6 years, we are working deeply with the community on AI engineering, because we need to revisit all the engineering practices, software engineering especially, and system engineering also, in order to take into account of the specificity of AI. Meaning that we have to develop data engineering, of course, in order to reduce bias, to be sure that the data are relevant with respect to the problem, and so on. But we have exactly the same question for knowledge engineering, in order to identify the adequate knowledge in order to solve the problem, to acculturate all employees, and so on. So it's a new wave, especially for critical industry, through a new discipline which is called AI engineering.
Dominique, Mihir, any thoughts?
Yeah, maybe I'm going to jump on that one. I think that we are trying to, and I think I have seen that many times, what you want to solve, it's to solve an industrial problem. So I would say a scientific problem with an AI. And very often the mindset of these two people totally different. So making them work together in order to develop, the right tools that can analyze the right data and can make the good assumption, it's something that is critical. And I think this is something that's failed many, many times because, it's like making two different people work together that they never work. So I guess before. The other thing, what Mireille had said, it's you should not only consider AI as a mathematical calculation, you should add a reasoning behind. And the reasoning behind, I'm calling it causality. So the reason why this is happening. And this is helping a lot in better understanding what should be, how the AI should think in order to give the good result or the good suggestion to the scientist in order to develop the next thing. And the last point I wanted to add here is that many times we are not solving the right issue. Like, in the protein space, I've seen many people, and even now you have plenty of AI company trying to focus on the structure of protein. But if you don't understand under which condition this protein, this structure is going to work and express its functionality, you're not solving the problem. So I think it's a combination of all of them. And I think we are learning from mistakes, but we are in the phase where we can do much more.
So maybe thanks Dominic and Juliette, maybe I'll jump in. And so some of the things that we've seen and that we see and that we've worked on, one is something that many of you will be familiar with, which is a multiplication of proof of concept, of POCs and pilots, and very few use cases that actually make it into production, that scale, that are deployed and adopted. And we see a lot of disconnected pilots and no clear path to industrialization. And we see a lot of, it's almost like a portfolio of experiments and not a real transformation that lies behind it. So what we've worked on in that respect is around creating an operating model with the process that combines an agile way of working with a stage gate process where we can take decisions of stopping projects that don't lead to industrialization or adoption sufficient, that don't create the value that is expected, where the ROI may be not realized, and that may be on pause because there is a lack of maturity either in the tech or in the data or in the business environment. And taking those decisions early instead of leaving those projects to live their life enables to assign resources to the right use cases that will then make it to production and industrialization. The second aspect is around ownership of both the data and the use cases. And that's a question of governance. The fact that who owns the AI system, who owns the data that we need to feed into the systems. Very often the data that is the input to those models, the teams that are responsible for the data are not the ones that will necessarily benefit from the results of the AI model. So how do we incentivize them to make sure that the data has the level of quality that needs to get into those systems so that everyone works together? And the question of governance is really important in making sure that we have clear ownership and accountability in delivering those systems. And the third aspect, I think, is the question of adoption and integration. We know that change management is notoriously difficult. It's been for a long time a very top-down approach, or with agility and user-centric approaches, maybe a bottom-up. I think we need a combination of both in terms of, like Dominic mentioned, generating the right mindset. And I think that mindset is even more important when we talk about AI, because the tools are evolving so rapidly that all of us need to question regularly, continuously, the way that we do our work and the tools that we're going to use. For a long time, digital transformation or IT transformation was about matching the tools to the process. When we talk about an ERP system or a CRM system, the tool is the process. It describes the process. We're very far from that in the world of AI, industrial AI, especially in terms of operations. The tool is an addition at the moment, and those tools are evolving very rapidly. So beyond the question of governance, we need to have the right mindset of people to take into account those tools, soon people from the business are going to be able to develop their own agents and tools themselves instead of relying on third-party developers to, whether internal or external, to develop those tools. And the question then becomes of how do we make sure that we can integrate the whole value chain from data input to integrating the systems with each other, and orchestration of agents and integration of interfaces becomes very important in those respects. And then how do we integrate systems of systems so that we think about outcomes and not just a process-based approach.
Interesting. So we come back to really the human vs AI a bit intricacies, how to make the two work together, how to make people who work with AI work with the people working on the deeper use cases to start with. That is interesting to see that challenge emerging from across industries. Dominique, Juliette, do you have a last comment to make on Mihir's last words, or should we move on to the presentation in Q&A?
I just want to underline what it was already explained, that if we want to develop an AI systems and to move from a proof of concept to a real solution, it's very useful to have a system approach and not a data scientist approach. Meaning that we need to solve an issue, or we need to bring new capacities. And it is why, for example, in THALES, we create a new job, which is not a data scientist, but an AI scientist with the spirit of a real software or system engineer, but with also all the skills in AI and not necessarily in data-driven AI. So the first step is to understand what is the capacity or the intended purpose of the solution. The second step is to identify the right AI solution or the right AI techniques, because most of time people will choose data-driven AI or generative AI, but the way to solve the problem could be symbolic AI. So please identify the problem, then choose the right solution, and then identify also all the requirements, such as robustness, such as explainability, and so on, in order to best develop the solution, and the journey towards the industrial solution will be easier.
Thank you, Juliette. So to summarize on the question of the roundtable, it's really a governance issue in many ways, right? Of having the right changes in the right places across the organization, even from job titles all the way to just working together, relationships, and choosing BI models. But it's being aware of all of those tiny changes that need to be made for this wider change to happen in a successful manner. Thank you. So we'll have a short presentation by Ming-Xu before we move on to the Q&A, to also give time to everyone to post their questions. I see we have 3. So Ming-Xu, I give you the floor, and then we'll go back to the speakers for the Q&A answer.
Yes, thank you, Fanny, and thank you for our speakers for the wonderful discussions. And of course, I realize that we really need to have a longer webinar so we can have more interesting opinions afterwards. And we've seen that actually across industries, how AI is driving value, and like finding the high impact use cases is important, but turning them into the scalable capabilities is just as critical. That's one of the reasons that we are organizing this webinar today and bring all of us together. And beyond this session, we'd like to go deeper and invite you to our exclusive deep tech ecosystem at this year's Hello Tomorrow Summit, where more dynamic interactions and opportunities can emerge. So as Fanny mentioned earlier, the summit is one of the most curated deep tech events, and the summit welcomes over 3,000 participants each year. Within this community, we are enabling each attendee to stay at the forefront of emerging technologies and industrial transformation. And during the How Tomorrow Summit, we bring together an unusually broad spectrum of sectors in one place. And also thanks to the How Tomorrow Challenge, we have direct access to the most promising deep tech pioneers worldwide, also covering the different sectors. In the context of How Tomorrow Summit, we've designed the Corporate Business Pass. It is a dedicated program for corporate leaders that sits on top of the full 2-day experience and focuses specifically on AI in industry. In 3 hours, participants move through 3 high-impact activities, which are listed here. On the left is the masterclasses that we will work with you to identify the highest value AI use cases for your business and define concrete next step towards the implementation. And in the middle, afterwards, during the collaboration lunch, all the corporate leaders will break into small groups to benchmark how others are structuring AI and innovation and to build the arguments that you need to win the internal battles for your flagship AI projects. Finally, through a curated startup tour, we will introduce you to the most relevant founders of different startups for your needs. And in fact, we encourage you to share in advance what you are looking for in terms of the topics, the technology maturity level, and the geography. So we can really make every meeting counts and maximize the value for you in terms of that. And also aligning with today's topics, 3 sub-themes for R&D to operations to sustainable value chain. And we will cover more in depth than we explore today due to the limited time. Follow this webinar. We are delighted to invite you to join us at the summit for the full experience. And so the Corporate Business Pass offers a tailored 3-hour program that will be on the first day, in addition to your full access to the summit. And throughout the event, you will also be able to participate, of course, in all the panels, interesting sessions, and networking opportunities across the ecosystem. The goal is actually, instead of offering a shallow and just a note-taking session, we designed this program for the corporate leaders so you leave with really tangible outcomes, like a strategic roadmap for AI in your business, or a short list of startups in your partnership pipeline, a high-value network of peers, and concrete case studies. And by the end, you will have 2 to 3 use cases you can personally sponsor, each backed by a clear story on cycle time reduction, probability of success, and impact on your overall innovation portfolio risk. So who is attending? The director or managers from corporates in terms of innovation and corporate strategy, all the leaders from the BUs and the R&D and product leaders will be expected. And here are the examples of our attendees from Denora, Sensco, Breakthrough Energy, and ABN AMRO, and more to come in the next few months. The link will be shared in the chat afterwards, and the price for the Corporate Business Pass is at 2,450 euros. And as I mentioned, it's the one access to all the activities that we have seen before, and also we'll have the added benefits, including the reserved seating at the keynotes, early access, and of course the matchmaking platform that help you to connect with the right people in terms of startups, investors, and all the fellow innovation leaders. So basically that's the presentation of today, and I think we will be so delighted to move into the Q&A question, and we've seen already there are some interesting discussions in the chat already.
Thank you, Ming-Shu. And don't hesitate to write to either myself or Ming-Shu for any questions on the webinar or the Corporate Business Pass. We'll move on to the question. We'll try to address them as efficiently as possible because we have quite a few questions in the chat and limited time. So the first one chronologically, which was posted from Ioannis, me here was for you. It sounds like you're building all this internally versus working with SaaS business to such as AI-enabled services. Do you think that model, build vs buy, will persist? And if so, why is that?
So yeah, I think that's a really good question and one that we grapple with. So just as a context, we're an equipment operator. We're not a manufacturer, so that changes things in terms of how we view the way that we think about systems. And I think we need to work with startups. We need to identify what the market is doing, what is coming out of research, academic and industrial research, and what the gaps are where we can bring value in-house. We have limited resources, so our teams in-house need to focus on what's very specific in our business and the way that we can apply AI models. So we have in the past started projects that we then ended, and I was talking about the stage gate process that helps us make those decisions. But even if we stop projects because a reason is that there's a market solution that appears, there are still learnings and acculturation and change. And the mindset of experimentation is important in the journey of change and transformation. So there's always learnings, and I think it's always useful to start projects even if something may come up later. One of the other aspects also that we can differentiate ourselves when we think about what the gaps are compared to what the market brings is the fact that we have a combination of data that comes from our assets with expertise from the technical teams and the operators on the field with the capacity to develop AI models. And very often we see that actors on the marketplace have two of those three, maybe not all three. And therefore, we can bring something in the upper application layers that can bring value in addition to what exists. And there are very specific operational constraints, regulations that depend on geographies or things like that, for example, that need to be sometimes taken into account. So we really want to focus on the very thin application layer and not build the whole foundations that can be found on the market. And the last word on that is the fact that I believe strongly that we need to work with the ecosystem of actors, whether it's academic research, public policy institutions, startups, etc. And then only if we leverage that whole ecosystem can we make the field advance as a whole.
Thank you, Mihir. We move on to Valerie's question on many organizations still approach AI as a series of pilots, yet all of you pointed to integration and system level thinking as a real challenge. Do you think most companies are structurally incapable of scaling AI today? And if so, what needs to fundamentally change in how they are organized or governed?
I think that I've already answered. But for small company, at least in France, there are some associations such as the Hub Francia. In Europe, there are also other associations that could help in order to make this gap. But we have to organize, or at least to put in place a real governance inside the company in order to acculturate the employees, to train the engineer, and also to work together, because when we go to a real solution, it's not only an issue of algorithm or data scientist or AI scientist, it's also an issue of engineers such as system engineer, software engineer, safety engineer. It's dependent on the purpose, but it was already discussed. So trainings, governance is fundamental.
And maybe to add to what Juliette said, I think I have a very strong belief that in the future we will need multidisciplinary profiles, not just teams, but domain experts that become themselves familiar with how to develop their own AI agents, and that convergence of skills within people is going to be critical.
It's in fact for today we have AI plus domain expertise, but in the future we will have X plus AI, domain expertise plus AI. Yeah, completely agree.
Interesting. Thank you for that. So we're 11 a.m. already. Maybe we'll do one last question before we leave you. The one by Michael was asking, how do you cope with conflicting roles and not invented here syndrome, where everyone claims to be an expert in the buzz field, especially in matrix organizations?
Wow. It's also a question of governance, at least for a huge group such as Thales. It is why Thales has put in place a strong governance, at least for research technology and innovation. First, in order to be at the state of the art, and sometimes when it is very relevant, to make the state of the art. So the first question that we ask to engineer is, are you sure that there is no already existing solution? So we try to avoid the NIH syndrome.
Okay, thank you for that. Okay, well, we were so efficient. Maybe then let's do one last one. Do you think we can reach one day a full autonomous algorithm like agenting AI into critical systems? That I think is for you, Juliette, as well.
For the moment, no. Maybe in 3 or 4 years, yes. But we have first to demonstrate that all the requirements are there. So it depends on what each agent embeds, because the complexity will increase in order to prove the robustness, for example, or this kind of things.
Okay. Well, we'll stop here for now to be mindful of everyone's time. Thank you very much to you, Juliette, me, Dominique, Mingxu for joining, and to all of the attendees. We'll continue these discussions at the summit, as Mingxu mentioned, with the corporate business fast, to dive even deeper into real use cases for your organizations. And we will send you the live stream or the stream of the webinar by email so that you can watch it again. Don't hesitate to email us if you have any other questions, and we'll be very happy to answer, Mingxu and I. Thank you all again.
Thank you. Thank you.
Thank
Bye.
you all. Thank you. Bye-bye.
All right.